Hi, this is video 2 of Math SAT Prep, and today we'll be talking about rate of change. For a line, the constant rate of change is the slope of the line, and the slope is constant no matter what 2 points you calculated it on the line. Hi, this is Math SAT Prep. This is video 2, and today we'll be going over rate of change. So for a line, the constant rate of change is the slope of the line, and the slope is always constant. And you can see from this diagram here. And for a curve, the average rate of change is the slope of the secant line that passes through the 2 points. And the secant is a line which passes through 2 points of a curve, which is shown here. And that's how you find the average rate of change of a curve. So like a quadratic function or a cubic function. So let's look at question 1. What is the average rate of change of f of x equals to 1 over 2 x squared minus 4 as x changes from 0 to 4? So how we do this one is we have to find 2 points, and the 2 points that is given, the 2 x coordinates that are given are 0 and 4. And since we have the 2 x coordinates and we also have the equation, we can plug those 2 x coordinates inside of the equation, and we can find their respective y values. So when we plug them in, we get these values. And with these values, we have these 2 points. So we have 0 and negative 4. That's one of the points. And the other point would be 4 and 4. So we want to find the average rate of change. So then we use the slope formula, which is m is equal to y2 minus y1, rise over run, over x2 minus x1. And when we plug those in, we get 4 minus negative 4 over 4 minus 0, which is just 8 over 4, which is just 2. And that means our answer is A. Good. Let's move on to question 2. If an object is dropped from a cliff, then the distance in meters it has fallen after t seconds is given by the function dt is equal to 4.9 t squared. What is the average speed, average rate of change over the interval between t equals 1 and t equals 3? So when you have an equation and it's giving you 2 x values, well, in this case it's t, you just do the same thing and plug those x values in to get their respective y values, and then you plug it into that average rate of change formula, which is just a slope formula, and then you'll find what the average speed is or what the average rate of change is. So let's do that really quickly. D of t is equal to 4.9 t squared, and then when you plug 1 in, you should just get 4.9, and when you plug 3 in, you should get 4.9 times 3 squared, which is 9, and then 4.9 times 9. When you enter it in your calculator, you get 44.1. So now the 2 points you have are 1 and 4.9, and 3 and 44.1. And then what we do with these 2 points, we plug them into the formula, to the slope formula, and we get something like this. And and then this simplifies to 19.6 when you plug that into your calculator. 19.6. Okay, good. Let's move on to the next question. A flower plant is measured every day t. The height h of t in inches of the plant can be modeled by the function which is shown in the graph and table above. Find the average rate of change in height from 10 to 70 days. Okay, so right now we're given a table and we're also given the graph. So these two things both give us coordinates. So question 3 wants us to find the average rate of change from 10 to 70 days. And you can see the respective y values, or the respective height, from t equals 10 and t equals 70. So when t is equal to 10, the height is 3.5 inches. And when t is equal to 70, h of t, or the height, is equal to 39.2. So what we do is plug those in to the slope formula to find the average rate of change. So it's rise over run, so it's 39.2 minus 3.5 over 70 minus 10. And then you should get 0.595 when you plug this in your calculator. And that should be your answer. Okay. Good. Let's move on to question 4. So which of the following intervals has the greatest average rate of change? To check this, we can kind of use just our eyes. So let's look at option A, from 10 to 20 days. How I like to think of it is, for every 10-day period is like how I want to think of it as like how much it's increased for every 10 days. So from 10 to 20, we've increased about 3.5 7.4 minus 3.5. It's like around 4. And then the next option is from 20 to 30 days. So let's look at 20 to 30, which is from 7.4 to 19.8, which is quite a big difference. It's like 12.4 different. There's like a 12.4 height difference. And then from 30 to 40, there's a 10 height difference. And then from 40 to 50, see here, that's like less than 5 difference. So just from that, we can see that the correct option should be B, because we can see from day 30 to day 40, day 20 to day 30, there's the biggest difference in height.